Okay, let's look at number 6. There it is. The diagram shows a path that is x meters wide, so you can see this is x meters wide, around a rectangular lawn which measures 10 meters by 8 meters. We need to write down an expression in terms of x for the area of the path. So what would be the area of this path running around the edge of the rectangular lawn? Well, that's difficult to see at this stage. What I can see, though, is that the overall area of the entire thing right here, subtract the lawn, would leave me with this path area around the outside. So let's see if we can do that, okay? So the area of the path equals the big rectangle minus the small rectangle. I'm just kind of writing down my thoughts here. Now the big rectangle, how would we find its area? Well, it's going to be length times width. What is its length? Well, I can see that it's got this 10 plus this, which we know is x, plus this, which is another x. So I've got a total of 10 plus 2x as my width of the big rectangle. I can use a similar procedure to determine that the length of the big rectangle is going to be 8 meters plus x plus x. That's a total of 8 plus 2x. And so our area then becomes the big rectangle, which is length times width, minus the area of the small rectangle, length times width, 8 times 10. And so now I've got an expression in terms of x for the area of the path. The area will be 10 plus 2x times 8 plus 2x minus 80. Part B, what is the width of the path when its area is 208? So the area is 208. Let's replace A, area, with 208. And I guess I should FOIL this out. So first terms, 10 times 8 is 80. Outer terms gives me 20x. Inner terms gives me 16x. And the last terms give me 4x squared. And then I'm subtracting 80 from that result. These parentheses are kind of superfluous. They're not really doing anything in this problem. So, oops, sorry. So let's get rid of those Let's get rid of those parentheses. And so I've got then 208 equals, so this is a positive 80, and it's going to cancel with this negative 80. So I'm left then with only 4x squared and a total of 36x. Now, you remember that we're not allowed to divide every term by a variable. You cannot divide an equation through by an x. But we are allowed to divide an equation through by a constant. I notice that I can divide every single term here through by 4. So let's divide everything by 4. That's not illegal, dividing by a number. And that just makes the equation a little bit easier. Now I've got 52 equals x squared plus 9x. If I put everything onto the same side of the equation, then I've got x squared plus 9x. I'm moving everything to the right, actually, because x squared was already a positive. I want to leave it on the right. And so my 52, as it comes across, will become a negative 52, and I'm left with a 0 on the left. So I need to look for two numbers that multiply to give negative 52, that one of them must be positive and one of them must be negative, and they add to give a positive 9. Ooh, so the positive number was very dominant. It was dominant by 9. So we need to look for two numbers that are 9 units apart, which multiply to give 52. Little bit of work will show you that those numbers are positive 13 and negative 4. And so using the zero product property, either x plus 13 is equal to 0, which means that x is negative 13, or x minus 4 equals 0, which means that x equals positive 4. Now let's just think about these answers here. Is it possible for the width of the path to be equal to negative 13? Obviously not. You can't have a negative width, because that's a length, a dimension, a distance. So the only remaining solution is x equals 4. I should probably substitute it in to my equation just to make sure that this works. But in the interest of time, I'm just going to move on from this problem. The only thing that I realize I should have added is units. IB will deduct if you leave out units. So 4 meters, there we go. That is the width of the path. Number 7. The perimeter of this rectangular field is 220. What is perimeter? It's the sum of all of the sides in the figure. So we've got an x on the bottom and an x on the top, a w on the right and a w on the left. So if I add all these together, x plus w plus x plus w, I get a total perimeter of 220. This could be simplified a little bit because I've got two x's, and I've got a w plus another w, that's 2w, equals 220. Now it wants us to express the width in terms of x. That means that we need to isolate the term with the w in it. So let's put the w by itself, the 2w, meaning that the 2x will have to move to the other side and become a negative 2x. But they're not asking us to isolate 2w, they want us to figure out what 1w is, the width. So let's divide everything through by 2, and we'll get w is equal to 110 minus x. Part B, we need to write an expression in terms of x only for the area of the field. Well, obviously area is length times width, which in our case is x times w. But we want it to be entirely in terms of x, which means we can't have a w in here. What can we do? We can replace the w with something that it's equal to. 110 minus x. That gives you 110x minus x squared as your area. Part C, if the length is 70, find the area. So our area then, we know is 110, and now our x value is 70, it's been given. So 110 times 70 minus 70 squared. I'll do this on the calculator. So I've got 110 times 70 minus 70 squared, giving me an answer of 2,800. Let's think about units, because this is a physical quantity. We're dealing with meters, and because it's an area, which is a two-dimensional shape, meters squared. In fact, another way you can see meters squared is because we had x meters times w meters. The meters multiply, giving a meter squared as your area. Last problem is number 8. The length of one side of a rectangle is 2 centimeters longer than its width. You'll notice that we have not been given a diagram in this problem, so that's the very first thing I'm going to do. I'm going to draw a rectangle. It says that the smaller side is x centimeters, so here's our smaller side. And it says that the length of one side is 2 centimeters longer than its width. So if x is the smaller side, the longer side must be 2 bigger than that width. Alright, we need to find the perimeter of the rectangle in terms of x. Well, we've already learned that perimeter is going to be the sum of all of the 4 sides. So perimeter is going to equal, well, I've got x plus 2 plus x plus 2, the 2 lengths, and I've got my 2 widths, x and x. Doesn't matter the order in which I add them. And that means that the perimeter gives me a total of 4x plus 4. Part B. The perimeter of a square is equal to the perimeter of the rectangle that we've just discussed. what will the length of each side of the square be in terms of x? Now let's think about a square. Square has got 4 equal sides. Let's call them all s. So the perimeter of a square is 4s. But we know that the perimeter of this square is equal to the perimeter of our rectangle. So our perimeter, 4s, must be equal to our rectangle's perimeter of 4x plus 4. They wanted us to figure out the length of each side of the square, which is an s, in terms of x. So basically, in order to get s alone, I've got to divide the entire equation through by 4. So this divides by 4, this divides by 4, this divides by 4, and s will be equal to x plus 1. The sum of the areas of the rectangle and the square they've given you is this expression. We actually could have found this without them telling that to us, but well, maybe I'll show you quickly. Let's figure out first the area 1 of the rectangle. That would be, of course, x times x plus 2, length times width, which gives you x squared plus 2x. And then the area of the square, would be x plus 1, because that's the length of the side, times itself, squared. And so let's just write that out in full. X plus 1 times itself, if I FOIL, will give me x squared plus 2x plus 1. And so the total area, the sum of these areas, would be this one, all of this, plus all of this. How many total x squareds do I have? I've got 2x squared. How many total x's? 4 x's. And how many total constants? Just 1. And you can see I got the exact same expression. But the question gave it to us for free. They were maybe worried you wouldn't be able to come up with it and do part C on your own. So it tells us that the sum is 49 centimeters squared. So our sum is 49. And now we need to find the area of just the square. Well, I guess I better figure out what x is first. And once I've got x, I can add 1 to it in order to get its side length of the square, and then multiply it by itself to get the area of the square. Let's just go one step at a time and first figure out what x is equal to. Good way of doing this might be to bring everything to the same side of the equation. My x squared is already a positive term, so let's bring the 49 over to the right side of the equation where it becomes a negative 49. And positive 1 minus 49 leaves me with negative 48. I suppose I could use the poly root finder at this point on the calculator, and I could put in 2, 4, and negative 48. Or I could maybe factor the expression, divide everything, I can see a common factor of 2, or I could even divide the entire equation through by 2. Dividing an equation by a constant is okay. Now you couldn't take just an expression, like let's suppose you had the expression 2x plus 6. You can't divide that by 2 just out of the blue, because it's not inside an equation. You would be changing the value. But if you had an equation, and you divided the left side by 2, whatever we do to the left side, we must also do to the right side in order to keep the equation balanced. And you end up with something like this. But here we're talking about a completely different problem, and just reminding you what you are and are not allowed to do in mathematics. Thinking about all of the different solution techniques available to us, I would imagine that poly root finder is going to be quickest. I'll do that in a minute though, because I think that we need as much factoring practice as we can get. So let's look for the common factor. It's 2. I'm left with x squared plus 2x minus 24. I want to factor it out of every term. And now I'm left with a 1, 2, 3. 3 terms. That must be a trinomial. So I'm looking for 2 numbers that multiply to give negative 24 and will add to give positive 2. Those numbers are positive 6 and negative 4. It's an easy trinomial factorization because it has a leading coefficient of 1. Now I factored it. One of these 3 factors must be equal to 0 according to the zero product property. That's why it's so important to put a 0 on one side of the equation before you start. So either 2 is equal to 0, ridiculous, or x plus 6 equals 0, which means x is negative 6, or x minus 4 equals 0, which means that x is equal to positive 4. Now let's just think about these solutions. Is it realistic that x is equal to negative 6? I would say no, because if x was equal to negative 6, how could our original rectangle exist? How could you have a width of negative 6? Or you could say negative 6 plus 1 gives you negative 5. How could you have a side length of negative 5? So we need to throw out the x equals negative 6. It's not a valid solution in the context of this particular problem, leaving us with only x is equal to 4. Now the question isn't asking us for x. The question is asking for the area of the square. We know that the area of the square is x plus 1 all squared. So if the area of the square is equal to x plus 1 squared, in our case that's 4 plus 1 squared, and 5 squared is equal to 25. Let's put in units to finish off. We've been dealing with centimeters the whole time. An area is a two-dimensional shape, so it happens, oh dear, what's going on? Sorry, my thing's freaking out. There we go. So 25 centimeters squared will be the area of the square. And that's it in terms of the questions on this review. I think that it maybe would be helpful for you guys to see just one example of how to factor a trinomial where the leading coefficient, where the a value is not equal to 1. So let's suppose I give you this problem. And so the question then is, how would you factor this expression? Alright, it's a trinomial, so I can't use a difference of squares. A difference of squares is when you have only two terms with a subtraction in between them and they're both squares. Clearly not the case here. So it's not going to be one of those a plus b, a minus b situations. It's a trinomial where the a value is not equal to 1, and that requires us to do this extra step at the beginning and a couple of extra steps afterwards. Let's begin by multiplying the outer numbers. 4 times 3 gives me 12. So I'm looking for two numbers that will multiply to give positive 12 and will add to give 7. Pretty quick to get these, isn't it? Those numbers are 4 and 3. So what I'm going to do is take my middle term and split it up into two smaller terms, the plus 4x and the plus 3x. So my 7x has just been re-expressed as 4x plus 3x because the 4 and the 3 was the answer to my little puzzle. Now then, let me examine just my first two terms. I've got a common factor of 4x, and if I factor out the 4x, I'm left with just 1x plus 1. And in my second two terms, I have a common factor of 3. If I factor it out, I'm left with x plus 1. Now I can see a common factor of x plus 1 in each of these halves of the big expression, so the x plus 1 will factor out, and first it's multiplying a 4x, secondly it's multiplying a positive 3, and that's how you factor a trinomial if the leading coefficient is not equal to 1. Alright, good luck studying for this quiz. Bye-bye.